tsunami or waves caused by earthquakes are unusually large ocean waves because tsunamis are so big they can cause incredible destruction and loss of life. The height of a tsunami or other wave is just one way of measuring size. How to measure wave amplitude? Wave amplitude and wave length are two important measures of wave size. Height of a wave is its amplitude. Wave amplitude is the maximum distance particle of a medium move from their resting position when wave passes through. Resting position is where the particle would have been in the absence of a wave. In transverse wave amplitude is the height of each crest above the resting position. The higher the crests are, the greater the amplitude. In longitudinal wave, amplitude is to measure how compressed particle medium become when the wave passes through. Closer together the particles are, the greater the amplitude. What determines the wave's amplitude depends on the energy of the disturbance that caused by the wave. A wave caused by a disturbance with more energy has greater amplitude. Imagine dropping a small pebble to a pond of still water. Tiny ripple will come out of from the disturbance in concentric circles. Ripple are low amplitude waves. Now imagine throwing a big boulder to the pond. Very large waves will be generated by the disturbance. These waves are high amplitude waves. How to measure wavelengths? Another important measure of wave size is wavelength. Wavelength is the distance between two corresponding points on adjacent waves. Wavelength can be measured as distance between two adjacent crests of a transverse wave or two adjacent compressions of a longitudinal wave. It is usually measured in meters. Wavelength is related to the energy of a wave. Short wavelength waves has more energy than long wavelength wave of the same amplitude. Waves have the same amplitude, but they differ in wavelengths. Which wave have more energy? How to measure wave frequency? Imagine taking transverse wave into a rope, tie one end of the rope to a doorknob or other fixed point, and move the other end up, down with your hand. You can move the rope up and down slowly or quickly. How quickly you move the rope determines the frequency of the waves. The number of waves that passes a fixed point in a given amount of time is wave frequency. Only frequency can be measured by counting the number of crests or compression that passes a point in 1 second or the time period. Higher the number is, greater the frequency of the wave. The SI unit for the wave frequency is hertz, where 1 hertz equals to 1 wave passing a fixed point in 1 second. Transverse wave with a high frequency has crests that are close together. The frequency of a wave is the same as the frequency of a vibration causing the wave. For example, to generate a higher frequency wave, your rope must move the rope up and down more quickly. It takes more energy, so a higher frequency wave has more energy than a lower frequency wave, the same amplitude. How to calculate the wave speed? Assume that you move one end of the rope up and down just once. How long will it take the wave to travel down the rope to the other end? This depends on the speed of the wave. Wave speed is how far the wave will travel in the given amount of time, such as how many meters travels per second. Wave speed is not the same thing as wave frequency, but is also related to frequency, also to wavelength. This equation shows how three factors are related. Speed equals wavelength times frequency. This equation, wavelength is measured in meter and frequency measured in hertz, or number of waves per second. Therefore, wave speed is given in meter per second. The equation for wave speed can be used to calculate the speed of a wave when both wavelengths and wave frequency are known. Consider an ocean wave with a wavelength of 5 meters and a frequency of 1 hertz. Speed of the wave is speed equals 5 meters times 1 wave per second equals 5 meters per second. The equation for wave speed above can be rewritten as frequency equals speed divided by wavelength. Wavelength equals speed divided by frequency. Therefore, if we know the speed of a wave and either wavelength or wave frequency, can calculate the missing value. For example, suppose that a wave is traveling at the speed of 3 meters per second, has a wavelength of 1 meter. The frequency of the wave is frequency equals 3 meters per second divided by frequency equals 3 meters per second divided by 1 meter equals 3 waves per second, or 3 hertz, with a relation between medium speed. Speed of most waves depend on the medium through which they are traveling. General waves travel fastest through solids and slowest through gas. That's because particles are closest together in solids. For the part in gas, when particles are further apart, it takes longer for the energy of the disturbance to pass from particle to particle. Organized a famous Maverick server contest and voted conditions are right for the Hamilton this weekend. Monster waves and Mavericks travel bigger wave servers from around the world. But what exactly makes these big waves so big? I make a summary. Wave amplitude is the maximum distance of the particle of medium move from their resting position as the wave passes through. Wavelength is the distance between two corresponding points adjacent waves. Waves with greater amplitude or shorter wavelengths has more energy. Wave frequency is the number of waves that pass a fixed point in a given amount of time. Higher frequency waves have more energy. Wave speed is calculated as wavelength multiplied by wave frequency, wave speed, affected by medium through which wave travels. That's it. Thank you very much. I want image go kind of number 2 and 2 Life by J. Bach.